So again, as we move through curves, circles, and now we get into some polygons, we've now moved into a four-sided polygon, which we call a quadrilateral. So a quadrilateral is a four-sided polygon. Remember, these are going to be what we call convex polygons as well because they're closed. So a quadrilateral polygon has four sides, four vertices, and four angles. Now, the interior angles of a quadrilateral actually add up to 360 degrees. We may talk about that more later. Uh, so the main types of quadrilaterals is the square, which you should be familiar with. So if you want to pause the video and make notes of what a square is, you can. We have a rectangle. So again, you can just pause the video and make your notes here. So those are the most familiar we are as well as the square and the rectangle. We know how to draw those. What you may not be familiar with is a rhombus. So a rhombus is a four-sided shape as well, where all four sides are equal, but the angles are not equal. A lot of times when I draw a rhombus on paper, I usually draw, whoops, took off on me here. Let me pause my video for a second. So in drawing a rhombus, usually what I do is I draw a line segment and then I draw another line segment. It doesn't have to be the same distance, but it has to be cut in two equal pieces. So this segment and this segment are equal, and this segment and this segment have to be the equal. So this is what's called a perpendicular bisector. So when I do that, I can construct a rhombus by connecting the outer endpoints here. So rhombus kind of takes on this look here. So it's going to take on that look. So again, mine's kind of just sort of looks like my just trying to draw it freehanded is a little bit harder to do, but a square is a special rhombus. So keep that in mind. But a rhombus, the four angles don't have to be equal, but notice how the opposite angles will be equal. These opposite angles would be equal. So getting into a parallelogram, we have opposite sides are equal, but opposite angles are equal as well, and the diagonals bisect each other. So again, a square is a parallelogram. A rectangle is a parallelogram, but the catch about a parallelogram is it's not as specific. So in a parallelogram, all I got to do is draw two sides that are parallel, but they don't have to line up. They can be offset, if you will. So if I offset a little bit, but they have to be the same length. So this length and this length have to be the same. So then I just draw these two sides are going to also be parallel. So parallelogram is going to kind of take on this look here. So this side and this side are equal. But the catch is all four angles are not equal. But what is true is these opposite angles are equal. So notice how I use the same markings. So if I use like these two markings here and these two markings here, what that's saying is these opposite angles are equal and these opposite angles are equal. Notice that these are considered same side, and if you will, if we think about parallel, these are actually same side interior, if you will, and these are actually going to be supplementary. But the opposite angles are going to be equal, but the same ones are actually going to be supplementary, which means this angle and this angle would actually add up to 180 degrees. Another thing they mention is the diagonals bisect each other. What I mean by a diagonal is, if I can get me a, so a diagonal means you would start from here, go to here. This would, the diagonal kind of goes from opposite endpoints. And then if I talk about this one here and this one here, if I connect those two endpoints together, these are what we call diagonals. And what we mean by bisect each other is the fact that this distance and this distance is equal, and then this distance and this distance are equal. So bisect means it cuts it into two equal pieces. So those diagonals have a lot of characteristics going on here. But the diagonals themselves do not have to be equal. But now if I drew a rectangle or squares, notice how there's some different characteristics going on there with that. But notice how a parallelogram, a square is a special parallelogram. A rectangle is a special parallelogram because the angles are right angles. But a parallelogram, these angles actually have flexibility. So another type of quadrilateral, we have what's called the trapezium, or in the United States, we call it a trapezoid. So a trapezoid, what we have here are two sides that are parallel, but they're not the same length. So one's longer than the other. So trapezoid, we have opposite sides parallel, but they're not the same length. And when I join them together, we create, because remember, it's got to be closed to be a polygon. And since it's a four-side shape, it's called a quadrilateral. But this quadrilateral has a special name. This quadrilateral is called a trapezoid because this side is and this side are parallel, but also they're different lengths. Now, if these base angles are the same, then what's going to hold true is this side here and this side here would be equal. So this would create what we call an isosceles trapezoid. So notice how these are the non-parallel sides. Notice how they're going to be equal. That's going to be an isosceles trapezoid. A right trapezoid, what you would have is if you draw if they start out the same spot and one's longer than the other, a right trapezoid, notice how it has, notice it says one right angle. Um, so take that back. So a right trapezoid has exactly one right angle. That's not exactly what they're looking for. So that would actually have two. So we'll save that for later there. And then a scaling trapezoid, all sides are unequal. So we could look those up later on. Okay, most commonly we see is this one. Okay, so a kite has two pairs of adjacent equal sides and one pair of opposite equal angles. The diagonals are perpendicular. So a kite, I draw kind of like a rhombus. When I draw a kite, the difference is when I draw this, the diagonals will not bisect each other, but they will be perpendicular. So this will be perpendicular, but notice how this diagonal or this line segment does not bisect this segment. So when I kind of create this kite, it kind of starts to take on the look of an old-fashioned kite. So notice how it's saying that adjacent angles are equal. So what they're saying is this angle and this angle are equal, and this angle here and this angle here are equal. So that's what they mean by adjacent angles, or adjacent sides, I should say. And one pair of opposite angles are equal. So we could have these. Notice how these aren't equal, but these angles here are equal. So we have one pair of opposites angles equal, but these here don't look equal. So this is a quick review of the different types of quadrilaterals. So a square, we know that all sides are equal, all angles are 90 degrees. A rectangle, we have opposite sides equal, all angles are 90 degrees. A rhombus, all sides are equal, but we don't have to have 90-degree angles, not necessarily. So parallelogram, opposite sides are equal and parallel. A trapezium, or as we refer to it as a trapezoid, we have one pair of sides parallel, and then the kite, as we said, adjacent sides are equal. It's a good idea to kind of practice those, or again, you can go out to Google and just look for different types of shapes of those different definitions there. Okay, we'll stop there.